Good afternoon, everyone. In last lecture, we have completed Unit 10, which is PLSQL. And today we are going to start with a new unit, which is Unit number 5, Query Processing and Optimization. Okay. So first we'll see what is the outline of this unit. So as you can see here, we'll have different topics, like the first one is query processing, then measure of query cost, selection operation, join operation, evaluation of expression, query optimization, and equivalence rule. These all are the topic which is included in this unit. And now we are going to start with the first topic, that means what is query processing. So, query processing will refers to the range of activities involved in extracting the data from the database. What does it mean? Like this is a database. This unit is about query processing and optimization. Suppose I want that I need to fetch a data from this particular table named student. So what I can write is select star from student where student name equals to this. This is my query. So query, how it will be processed once you are firing this query, once you will write your SQL query here. So how it will be executed. Okay, so this query can be executed. So it will referring one table or more than one table which is available inside your database, and it will evaluate the result and it will give it to you as an output. So query processing, like how the query will process at the back end, it refers to the range of activities involved in extracting the data from the database. So how you are going to retrieve or access the data which is already available into the database. So query processing means this. Basic steps of query processing are parsing and translation, optimization, and evaluation. Okay. So in the query processing, we have a different step to fetch out the data from the database, and these steps are these three: parsing and translation, optimization, and evaluation. Okay. First, we'll learn what this three concept means, and we have a flow chart like how the query will be processed and optimized. So we'll take a look and identify this. So these all are the steps of query processing. Okay. First we'll see this diagram, then we'll go for each and everything like parser and translator. As you can see here, it is parsing and translation. The second one is optimization and then evaluation. So here optimizer and then evaluation engine. Okay. So we'll learn all of this concept. First we'll take a look. What does this diagram mean? So here we'll have a query. Okay, this query which I am just going to point it out, this query is written in SQL or PLSQL format. Like you can write select star from table name where you have some conditions like this. So this is a query which is written in the SQL format. But as you know that, like this SQL format is directly not interpreted into the machine code. So there is some process, there is some intermediate form. So if you are writing select star from student table and you are putting a semicolon, you are going to execute it. So you can understand what does the query means, because we know that select is one of the keywords, star means each and every column names, and from is again an SQL keyword, and whatever you have written after that from, it is a table name. So we need to refer that particular table into the database, and we are going to retrieve each and every column's value from that table. Okay. So the query which you are writing in the SQL format, which is a structured query language format, it is understandable by user side, but machine cannot understand what does this select star from student. So machine only dealing with zeros and ones. Zeros and ones. So if I am writing here 0 0 1 1 0 0 1 0 0 1 1 0. So it may possible like this 8 digits or 8 bits are identifying select keyword. So machine cannot understand what does this select means. It may possible right now I am writing 00 100 110 for select for machine A. It may possible for machine B there is some different formation like 4 times 0 and 4 times 1. It also possible. So it is different as per the assembler we are using. So we are not going in that much depth, but we are comfortable to write the code in this kind of language to access the database, and machine is comfortable to read the code in this manner. So we need some intermediate tool or thing which can convert user understandable programming language into the machine understandable programming language. Okay, so these steps are required to process the query which we have already written in the SQL format. So this query which is written in the SQL format, it will be going inside this parser and translator. Okay, what does this parser and translator means? Parser. Parser is generally used in compiler. Like you have written a code in Turbo C or code blocks, and you are pressing that Alter F9 for compilation of the code, or you have that compile code, you have some kind of a statement. After that, you are going to execute it either with this kind of a button or you can press Control F9. So parser means whatever the structure you are writing as a code, they are verifying it with the already existing grammar. For example, if we take a very simple example, then if I am writing this, I play cricket. Okay. Which language is this? Can anyone reply here in the chat box? I play cricket. Anyone? I play cricket. This is blank language. Which language? Quickly identify. Okay. Like, is it English, Hindi, Sanskrit, Marathi? Perfect. It is a human understandable language, and specifically it is English language. Okay. So how you have identified this is an English language? Because you know that in English language we have a statement which can have first subject, then verb, and then object. So is it possible like every time I can put here only I? No, it is not possible. Subject can be anything. I, we, you, he, she, whatever. You can put many a choice here for subject. There can be multiple way. You can put here a verb. It can be simple tense or past tense, continuous present tense, anything. And here is the object. Sometimes if you are not writing object, then also it is valid. Okay. If you are writing in passive voice, then the structure will be differing. But in common, we can say that this is a grammar for English language. Whenever we are dealing with any of the language, there must be some rules, some pattern, some grammar. Accordingly, will form the sentence. Okay. Just like if I am talking in Gujarati, so in Gujarati, we are saying that came cho. So there should be some word after that verb or anything in Hindi. So you have some specific pattern, some of the allowable words, and the pattern like here in English, subject, verb, object. If you are dealing in C programming language, then header file followed by a main function. So each and every language has some grammar. So whatever you are giving as an input, like here we have a SQL query. So DBMS SQL part or PLSQL part is also having some grammar. Some of the keywords like select is a keyword. You cannot use select for any of the table name. You cannot use any of the table name like order. Okay. So these all are the keywords, and a keyword for a particular language, that simply means it has some special meaning for that particular language. Okay. So we are dealing with DBMS SQL part. That simply means that parser will taking a input from user will provide you always the string. Like if I'm a user, so I can say that I play cricket or I play football or anything like that, or I'm watching movie, I'm taking lectures, but I'm not saying that subject verb object. So grammar I'm not saying, I'm just forming a sentence which is based on the grammar. So user will create this select query, select star from student, select star from TPC1 where mentor name equals to this. So it is not based on the grammar. Grammar can be select column name from table name where condition. This can be your grammar, but you are not directly speaking the grammar or writing the grammar. You are replacing the value wherever it is needed. Okay. So parser will verify if this is your grammar and if this is your SQL statement, then the statement is generated from the grammar or not. Do you have any kind of syntax error or not? To verify this, it is the task of parser. So parser will doing this, and the second one is translator. If your code is perfect, like select star from student, if this syntax is proper, then it will create a parse tree. Okay, this is a new term and we are not going in depth, but parse tree means like from grammar, how you can generate that statement. Like if this is an English language, statement can have subject, then verb and object. So subject can be replaced with I, verb can be replaced with play, and object can be cricket. So how I play cricket is belonging to this grammar. So this is called a parse tree. So this is how they will create a parse tree if this SQL query is the correct one as per the definition. Then it will create the parse tree. And now you are able to translate it. How we are going to translate it from SQL query to relational algebra expression. Okay, what is relational algebra expression? We have already covered in the unit number 4. Sigma, pi, division operator, if you remember. Okay, so these all are the types of relational algebra operators. So it will convert from SQL to this kind of a query. Meaning of both of this should remain equal. Like previously, if I have returned select star from student where mentor name equals to this. So if I am converting it to the relational algebra expression, then also their meaning should remain same. So this is the task of parser and translator. After that, there can be, if you can say, relational algebra expression query will have here at this point. Okay. Then we are giving it to optimizer. We have a multiple way. The same logic can be implemented in various format. Like you can put first sigma condition here, and then you can write here pi, or first you can select a column and from the entire table, and then you are going to give the condition. So there can be multiple ways to represent the query. So we need to identify the optimized solution of the query, and we are going to execute that optimized query. So it will take a usage of a minimum number of resources. So this is an optimizer. It will optimize based on the statistics about the data. Like if we are using the data, then how many tables they are going to use, how many processing is required, like this. So they can take a statistic about the data available into the database, and they are going to optimize your relational algebraic query. After that, you will have an execution plan. Like if you have selected this query, then how you are going to execute it. Okay, so this is a very simple query. We have just two operators, but if it is a complex one, then we'll have multiple operators. So if you have 2 times pi, 2 times sigma, so which one you will execute first? So you can decide a plan. Which pi will be evaluated when? If you have multiple sigma sign, which one be evaluated first? And once you have selected the plan, like how it will be executed, you can given it to evaluation engine. So this engine will have a data. It may possible they are using multiple tables or from a single table. They can evaluate this optimized query with the pre-decided plan. And after that, you will have an output which you can see as a result in the Apex Oracle. Okay, everyone is clear till this? Okay, good. So now we are going to learn with each and every topic. So steps of query processing. The first one is parsing and translation. So the first action the system must take in query processing is to translate a given query into its internal form. Okay, what is an internal form right now here with us? It is a relational algebraic expression. So parser will verify the syntax. If this query is following the proper syntax, then that query can be translated. If the syntax is wrong, then we are not going to translate it. We are just directly giving the error. So translator we are using here for transferring the query, SQL query, into relational algebraic expression. It is also called internal form. This is a relational algebraic expression. Okay. This translation process is similar to the work performed by the parser of a compiler. Okay, parser is also doing the same thing in compiler. In compiler, if you are giving a C language code, then it will check the syntax and going to translate it that the intermediate form which can be utilized by the rest of the phases. In generating the internal form of the query, the parser checks the syntax of the user's query, verifies that the relational names appearing in the query, suppose in query I am writing select star from student, so the relation name is student, so the same relation name is available in the database or not. If you are giving any name which is not available in the database, then they will give you an error like relation or a table does not exist. So it can be verified by this parser. The system constructs a parse tree representation of the query, which it then translates into a relational algebra expression. If the query was expressed in terms of view, like we have already covered in PLSQL, the first topic, create view. So if the query was expressed in terms of view, the translation phase also replaces all use of the view by a relational algebra expression that defines the view. What is a view? If you have these three tables, so from this three table, you are taking one column from here, two columns from here, and one column from this. And when you are having all of this thing, you will create one view which can just have the information of this four columns. Okay. So if you are performing any query on this view, so it also need to be translated. And the special care should be taken for that. The second one is evaluation plan. Okay, I have just changed the sequence because one of the thing term which we are using here in evaluation plan, which can be helpful to us in optimization. So a relational algebra operation annotated with instruction on how to evaluate, it is called an evaluation primitive. Suppose I have sigma, here is the condition, and Again, I have a sigma, one more condition. At last, I have pi like this. So, how we have evaluated, like which sigma will be evaluated first among these two, or first we need to evaluate this pi, or at last we need to evaluate this pi. So, we have multiple ways to perform the same query. So, what we are going to do is we will select the evaluation plan. So, we'll have a relational algebra operation, as you can see here, annotated with instructions on how to evaluate it. So which one will be evaluated first? We are going to identify the evaluation order, and it is called evaluation primitive. A sequence of primitive operations that can be used to evaluate a query, it is called query execution plan or query evaluation plan. Suppose you are deciding right now, like this sigma will be evaluated at the second position. This will be evaluated first, and at last will evaluate this. So individually it is called evaluation primitive, like they have their own sequence. And once we have all of this operations together, we can say that this is a query execution plan, like which thing need to be evaluated in which order. The query execution engine takes a query evaluation plan, executes that plan, and return the answer to the query. Okay, again we'll go back. This evaluation engine, it will take this evaluation plan as an input, like how we are execute this query. Accordingly, it will execute, and accordingly the result will be generated. I hope it is clear. Okay. The third step is optimization. So it is the responsibility of the system to construct a query evaluation plan that minimizes the cost of a query evaluation. Okay, what does the optimization means? We'll have optimized query which will have minimum usage, which will have minimum cost. So we can choose if we have multiple way, like if you are going from your home to any place and you have multiple paths to reach from source to destination, you are always choosing the optimized way. So you will have a minimum time to reach at the destination, and you can go with that way. The similar way, here we are choosing the optimized query or the optimized evaluation plan, and it is called query optimization. Once the query plan is chosen, the query is evaluated with that plan, and the result of the query is the output. In order to optimize a query optimizer must know the cost of each operation. Suppose I am writing here in one query, I am writing sigma one time, then we'll have sigma, and at end we'll have pi. In another way, we are writing sigma and we'll have pi, or any other way. So the same result can be achieved with multiple types of query way. So a query optimizer must know that what is the cost of each and every operation. Like this one sigma, what is the cost? What is the cost of this end? What is the cost of this selection or projection operator? This is a selection, and this pi means projection. So how we can identify the cost? We'll see it here after this topic. So the cost of each operation is ideally needed, and accordingly we can verify. If we have query number 1, which can have cost 40, query 2, which can have cost 60, and query number 3, which can have cost 37. So we can go with this query, and we can say that it is the optimized way of doing this processing. Okay, do you have any query till now? Do anyone have any query? I'm just waiting here for 1 minute. Okay, very good. Okay, so going ahead for the next topic, which is measures of query cost. Okay, we have discussed that in optimization we require minimum cost. So till now we understood about what is the query processing and what are the different steps for query processing and what is an evaluation plan. So a system can create multiple plan or a multiple way for a query. So the chosen method should be the best of all the possible ways. How it can be possible? It can be done by comparing each possible plan in terms of their cost of the operations. So if we are having cost, like we have just taken an example 40, 60 and 37, so we know that the minimum cost is the best one. For calculating the net estimated cost of any plan, first the cost of each operation should be determined and combined to get the net estimated cost of the query evaluation plan. Okay, what does it mean? There are multiple possible evaluation plan, like for the same query we'll have this three way we can execute the query in the relational algebraic format. So there are multiple possible evaluation plans for a query, and it is important to be able to compare the alternatives in terms of their estimated cost. We are writing their cost, but we are not going to calculate it accurately. It will take more time. So we are just roughly calculate it, and according to that we'll make the decisions. Okay. So here it is written in the bracket estimated. You are not going to identify the accurate cost. So it is important to be able to compare the alternatives in terms of their cost, and we need to choose the best plan from the all possible plans. We must estimate the cost of individual operations and combine them to get the cost of a query evaluation plan. Okay, so we need to identify what is the cost of an individual operation. This is one operation, then what is the cost and what type of operations we are using in our relational algebraic expression. We need to combine them all together, and we need to have a total idea of total how much cost this query can have. On the basis of this, we can have a better idea which query we need to select as an optimized query. So the cost of query evaluation can be measured in terms of number of different resources, which can include disk access, CPU time to execute a query, and in a distributed or parallel database system, the cost of a network communication. Okay, we'll understand this point. So what does it mean? We have to identify in this relational algebraic query plan 1 how many resources are utilized, like they are accessing the disk, like they are accessing the database table, how many times, which table they are using. If the same table is getting used multiple times for a different column, it is better because already we have values for that table. But if we are using different tables multiple times, so it will take more time. What are the different time to execute a query, like CPU cycle we need to consider. So how much time CPU is taking to process this particular query? And if it is a distributed or parallel database system, what is distributed system? Anyone? What do you mean by distributed system? Okay, anything you know about this distributed, you can write here in the chat box, then we'll discuss. Dhwani, Astha, Himangi, Krish, Kushal, Kumarpal, Zenith, Stuti, anyone? Okay, have you heard this term first time, distributed system? Yes or no? Have you heard this term distributed system first time, or previously you already know what the meaning is and you just go with that? Okay, Parth, right? That shared database system. Okay, anything else? Okay, so this distributed system means like suppose this is a central idea. This is a server of any of the company, or simply we can say this is a server of Google. Okay, this is a Google server. So it is located in USA. One more server is there, which is located in India. One more server located in Canada. Suppose these all are the based on the assumption. Okay, so these all are Google servers. They are located in different way. So distributed means geographically they are separated. Okay, so ideally the Google server should be at the same place. So we need to take care for the same place. No, it should be distributed in nature. Distributed means they are different in their geographical location. They are separated. It may possible like the timing of USA and timing of India are different. So if anyone is going to change anything here, like in USA, they are making a change. And in India, either it will be reflected previously or it will be reflected afterwards. So we need to sync this all things together. Okay. So we need to sync this, like the timings, or else the same thing, like suppose at 10:10 p.m. one person requests for change account for Gmail. And here at the same time, here also one person has tried. So if the timings are sync, if they are common, then we can take an idea like which person's request should be evaluated first, like this A person or B person. Otherwise, what will happen? According to Indian time, this person, if they have started previously, then also it will be looking that it will be receiving at the later time. If this Google server is at as per the India time, then this person is facing an issue, USA person. So we need to sync the time. The distributed system means they are separated in the geographical locations. So we need to also check that distributed or parallel database system, the cost of a network communication. So if they are geographically separated, so what does that mean? This is our database. So the database is at some different location and we are at some different location. It is not like we are in the different country. It may possible you are in the same city, Rajkot, but we are dealing here with this location and database is available at some different location. We cannot connect it with the wire. So the wireless communication is required. So the network communication, like this person A is firing here one of the query. So it will also taking a time from passing this query from this system A to database, and database is giving the answer. So this time we also need to be taken care into the calculation. Like if you are running in the same system, then this time will not be calculated. But if you are working in distributed or parallel system, then the cost of the network communication, like they are communicating through the network. So sometimes due to a network traffic, you will have a more waiting time. Okay, I think I lost the network. Should I repeat or can we go ahead? Anyone? Dhwani, Chinmay? Okay. Okay, so we are going ahead. For simplicity, we just use the number of block transfer from disk and the number of SIC as the cost measure. Okay, we are not going to take a consideration into all of this kind of resources. We are just going to take this into consideration like number of block transfer. Like if one block is storing some data, then to retrieve this data, total how much numbers of blocks from the database to the query result we need to transfer. From disk, that means from disk to our output, and the number of SIC as the cost measure. Okay, so here is the average time. This TT, it is an average time to transfer one block. If we have a disk, like this is our disk, and I'm going to give a transfer of one block from this disk to the main memory, then it will take on an average TT time. Okay. What is this TT? This is a dynamic value. It is every time changes. So we are not able to write it here, like it is difficult for us. The next one is TS. This is a time for one SIC. What is the time for this? The total number of SICs are required. So this is the time, average time for one SIC, and we can say that the total cost required for transferring B blocks. So if we are going to transfer B number of blocks, so it can be like B multiplied by TT, because one block transfer rate is TT. So if we have B blocks and each block is average taking a time of TT time, so it is B multiplied TT and S6. So we need to also pointing out it somewhere. So this is a S6. It is the required. So S multiplied by TS. Okay. The cost of all the algorithms that we consider, it depends on the size of the buffer in the main memory, the response time for a query evaluation plan, assuming that no other activity is going on in the computer, would account for all these costs and can be used as a measure of the cost of the plan. So what is the response time for a query evaluation plan? Query evaluation plan means if we have three different plans with us, like which I need to choose. So it is based on the cost, and we know that now how to calculate a cost, B multiplied by TT plus S multiplied by TS. So the response time for this plan, like if I am choosing this third plan, so what can be the response time? How much time I am getting my response as a result? So assuming that no other activity is ongoing in this computer, they are just working on our query evaluation. The response time of a plan is a very hard to estimate without actually executing the plan. I cannot say that the response time is always good, because sometimes due to some of the reasons, computer will take too much time to respond, even if they have a plan like this query I need to execute. So it is based on these reasons. The first one is the response time depends on the contents of the buffer when the query begins execution. So we have putting here a buffer. Why buffer is used? To speed up the processing. Like from disk to main memory, we are transferring a block. So at the time of processing, only some part is required. So the next time we are not going to take it from disk. It will take too much time. So we'll store it in the buffer. and in the buffer only we are going to process it. So the response time depends on the contents of the buffer when the query begins execution. This information is not available when the query is optimized. So previously, if you have a query, so you know that how much data we need to take from the database and we can store into the buffer. But if the query is getting optimized, so now you have an optimized query, so you will not have an exact idea what the data you can put here in the buffer. So it is hard to account for even if it were available. So it is difficult for us, and this is one of the reasons the response time, it is hard to estimate. The second reason is in a system with multiple disks, the response time depends on how accesses are distributed among disks. Okay, suppose we are dealing here with multiple disks. This is our disk 1, this is our disk 2, disk 3, and we have a data in the different disks. So how you can access this data from these 3 different disks? If we require from only 2 disks, but how to access the data from the disk? Because in disk we have multiple blocks. So how to search the data from the block, which is useful to us? So it is a difficult task. So response time is also depending like which accessing strategy we are having for this disk. How to quickly access the disk and get the data. So accordingly, it is identified the response time. So it is also based on this, and it is hard to estimate without detailed knowledge of data layout on disk. If you have a detailed knowledge, like in this, in first disk, we'll have 30 buffer, 30 blocks, and in a particular block, it is a space of this much bytes, and you can have a access. So if you have a proper index, then it is easy for you to identify. Interestingly, a plan may get a better response time at the cost of extra resource consumption. Okay, so measure of a query cost, that means how you are estimating a query. So it is totally dependent on the different reasons. The first one, we are identifying like the cost can be dependent on the different resources they are using and number of disks they are using, the transfer rate, everything will be taken into consideration. But here also we are depending on the response time, like if we have fired a query. So how much time a CPU will take and how much time quickly or how much time it will take minimum to respond to that query as an output. So response time means the time which is required to execute the plan, and it could be used for estimating the cost of a query evaluation plan. So these all are the reasons. So the last one, interestingly, it is like instead of minimizing the response time for any evaluation plan, the optimizer finds it better to reduce the total resource consumption of the query plan. Like if you are using 3 resources, now what we are doing is we are just going to use 2 resources. So automatically time to access the disk, time to access the table is reduced, and it is overall reducing our response time. Okay, everyone is clear till this? Yes or no? Okay, good. The next one is selection operation. Selection operation. What the selection operation relational algebra means? We need to select something based on the condition. We are going to select some rows from the table. Okay, so selection operation means in query processing, the file scan is the lowest level operator to access the data. If I have a table student and I want to access that particular table with some condition, so we'll have here a file scan. So the selection operation is performed by file scan, and file scans are the search algorithms that we are going to use it for locating and accessing the data. And we can say that it is the lowest level operator used in the accessing the database. So file scans are the search algorithm. If we are having this file, in this file, if we are having a multiple tables, so if by applying this selection operator, select all those record whose class name equals to 3PC1. So I need to check it one by one. And whenever this condition is satisfied, I need to select this particular record. So for that, we are using file scan, and file scan is nothing but a search algorithm. How you are going to search among the data which is available on the file. So we need to locate that particular record which satisfies the condition, and we need to retrieve that record who satisfied a selection condition. In relational system, a file scan allows an entire relation to be read in those cases where the relation is stored in a single dedicated file. So if it is available in the single file, it is easy to identify instead of searching in multiple files. So we have basically two scan algorithms, or we can also say two search algorithms to implement in the selection operation. The first one is linear search and the second one is binary search. Okay. What is a linear search? Can anyone reply here in the chat box quickly? It is a very simple one. What is a linear search? Quickly, everyone. You can write here the answer. Okay. So linear search means if I am saying that identify where I am having a dedicated file word. So what you are going to do, you are starting from here. You can just view this entire line. No, here not a dedicated file. Going here, then third line, fourth, fifth, sixth. Whenever you are at this seventh line, you have identified this dedicated file is available here. So this is called linear search. You are scanning line by line in your entire file. Okay. It is also called brute force algorithm. That means you are searching for each and every possible line. So in a linear search, they are calling this linear as a A1 algorithm and binary search as A2 algorithm. So in a linear search A1 algorithm, the system scans each file block and tests all records to see whether they satisfy the selection condition. Okay. So if I'm having this 3PC1 class list, this is 3PC1. So if I say that the student name should starts with capital S, so it will identify all of these records. So whenever here suppose student name is Stuti, so it will select this entire row. Again it will verify, so it will verify line by line. An initial seek means here the address, an initial address is required to access the first block of the file. If we have file and if we have multiple blocks, so to access this, we require the initial seek. Since the records are grouped into a disk block, each disk block is read into a main memory buffer. And then a search through the records within the disk block is conducted in main memory. If we have in multiple blocks and we are going to transfer it to the main memory, then the search will be done to this disk block in the main memory itself. Suppose we have PS as a seek time. Number of seek is usually 1 to reach the beginning of the file. We want the first address from where you are going to store the file. Like if you have a book and you want to read a unit number 10, so what you are doing, you can identify an index. In this index, unit number 10 is written on page number 236. So you will just open that page number and you can start reading from that. And we know that unit number 10, entirely all the concept will be in the same sequence. So here we are going to do the same thing. TT is the number of traversal time for one block and B is the total number of blocks which needs to be transferred from disk to main memory. So how the cost is getting calculated? Like this. TS, that means one time we want that the starting page we want, starting position of the buffer like a block, and after that number of blocks which we need to transfer. So this is TT is a transfer rate for one particular block and we have B number of blocks, so total B multiplied by TT. This is the cost required to fetch the record based on a non-key attribute. In a non-key attribute, it may possible like you have multiple records with the same value. Like I want all the student detail who is living in Rajkot city. So this is city name is a non-key attribute. Suppose we are searching on the key value like your enrollment number. So the cost will be almost half. Okay, TS plus B multiplied by TT divided by 2. So this is the average cost because we know that here the duplication is not allowed. Although it may be slower than the other algorithms, like it will search line by line, so it will take more time. But we can apply this algorithm to any file. This is the advantage. Regardless of the ordering, you can store data in any way. It will identify it if it is available in the file. Okay. So we need not to be worried regarding the order of the file, availability of the indices, or the nature of the selection operator. The next search is binary search. When you can use this binary? When you have ordered data. Like in dictionary, if you have A to Z. So if you want to search any word which is starting from C, like what do you mean by cat? So if you are going here, A to P, so we know that first we'll do a half portion, almost half, and then we can again do it half, and you can identify here it is. So the basic requirement is it should be in the sorted manner. So if the selection condition involves an equality comparison on a key attribute on which the file is ordered, this is an important one. File should be in the ordered way, like city name is written in the order. Afghanistan, then Bangladesh, then China, Denmark, like that. So if it is in order, so you can put here a binary search if you are going to put a condition on a city. Binary search, which is more efficient than the linear search, but the disadvantage, the order manner. This method of selection is applicable only when the records are sorted based on the search key value and we have an equal condition. For example, this method is not suitable for range or any other kind. So we need to give a specific value so it can compare it. Suppose block of records are stored continuously in the memory, then the cost of the query to fetch the first record is this, log B. It will take less time as compared to linear search, log B multiply TS plus TT. This is because we need to traverse for each record in a tree till child node. So we require here SIC. SIC means the address for each and every node. Like this is A node, this is Z node, this is P node. So we know that cat will be appear between these two. So again we need to change the address here for C. Okay. So time for SIC is not needed one time, it is needed every time. Log B time, and also transferring a block, it is also required log B time. So there are two different child nodes, design 1 and design 2. If you want to search anyone, so first you need to identify it starts with D. So just go to that particular character and then you can search linearly. Hence, we have seek time for each of them. Them means node, and transfer time for each of the nodes. Okay. So linear search and binary search. Do anyone have any query? Do anyone have any query? In the next lecture, we are going to start with join operation and all. Wait a minute, I'm going to take your attendance.